Dear students, today we will do some calculations about atomic mass unit. Atomic mass unit. In short, it is written as AMU. We know this is a unit which expresses the average mass of a nucleon. A nucleon can be a neutron or a proton. We know that a neutron is slightly heavier than a proton, but on an average, their mass is expressed in terms of atomic mass unit. Now, how do we define this atomic unit? Atomic mass unit, it is defined as 1/12 of the mass of carbon atom. These are some elementary details which you know from the beginning of your classes, but today we have to repeat them for certain purposes again. So that's why I'm expressing it again. So 1/12 of the mass of carbon atom is actually one atomic mass unit. Now we know that in terms of Avogadro's number, 6.023 into 10 to the power 23 atoms of carbon have a mass equal to 12 gram. We know that atomic mass of carbon is 12. So 6.023 and these many atoms of carbon weigh 12 gram. So one carbon atom weighs obviously 12 divided by this, and one atomic mass unit by definition is 1/12. 1 AMU is 1/12. That means it is 1/12 of this 12 by 6.023 into 10 to the power 23 gram. So 12 and 12 will go. We are left with 1 by this, and that comes out to be equivalent to 1.66 into 10 to the power minus 27 kilogram. This is further gram expressed in terms of kilogram. So this is on an average the value of an atomic mass unit. Since we know that neutron is slightly heavier than proton, neutron is almost mass of neutron is equal to 1.0086 times this atomic mass unit, and mass of proton is 1.0078 times this atomic mass unit. But on an average we can express that the mass of the two is 1.66 into 10 to the power minus 27 kg. Now we know the famous relation E equal to mc square. When we substitute for m this value, the average value, and for c the velocity of light, we get energy is equal to 1.49 into 10 to the power minus 10 joules. Now we can express the joules in terms of mega electron volt or electron volt. So we divide this value by 1.6 into 10 to the power minus 13. So that gives the value in terms of mega electron volt. And finally, when you calculate it, this comes out to be equivalent to 931 MeV. So one atomic mass unit, right? One atomic mass unit is equal to these many electron volts, mega electron volts. Again, I'm repeating it for you. We know that the average mass of a nucleon, that means a neutron or a proton, is expressed in terms of atomic mass unit. And atomic mass unit we know from the elementary classes that it is defined as 1/12 of the mass of carbon atom. Now we know that these many atoms of carbon weigh 12 gram. Therefore, one carbon atom weighs 12 by these many atoms. And one atomic mass unit is by definition 1/12. So it is 1/12 of this that comes out to be equivalent to this. We know that on an average, mass of neutron is greater than that of proton. So we write it like this, and E is equal to mc square use karke we get this. And finally, we divide this expression in terms of joules by this value to get the value in terms of MeV. Therefore, one atomic mass unit is equivalent to 931 MeV.